I just want to explain why differentiating an integral will give you back the original function. So something like with respect to x, with integral from a to x dt is equal to f of x. And we're not going to give a proof, but it's more of an explanation to help your understanding. This will be continuous. Hopefully you can even like it better than a proof. And a is just some real number. And we're assuming the definition of integral is the area between a and x of this function. So let's start with the definition of a derivative. Okay, so the definition of a derivative is the limit okay, and if you see how these integrals interact, the area from x to a will cancel with the area from x to a here, so you're left with just the areas from x to x plus h. Okay, and then there's a little bit of an explanation required for the next step. So if you look at the integral that we have, it looks something like this. It goes from x to x plus h. And it's this area. And what I want to say is that there's a point C in between here. Okay. Such that the function value at C times the width of this rectangle, which is h, is equal to the whole area. So what I want to say is that there is a C between x and x plus h, such that f of c times h is equal to the area under the curve. So if you think of this function, just this function as a function of x, so h f of x. So what that is, it's the area of the rectangle formed with height f of x and width h. And so if you think of f of x having a maximum and a minimum on this interval, then the area is going to be less than the maximum area when f is maximum, and it's going to be more than the minimum area when f of x is minimum. And since this is a continuous function, it should also cover every value in between those two minimum and maximum values. So therefore there is some value for which it actually exactly equals the area. Okay, and hopefully you could think about that for a little bit, but it's very similar to the principle that if a continuous function takes a positive value and a negative value, then it should also take the value 0, because 0 is in between a negative and positive, and to be continuous it should connect the negative and positive values. So if we can get it in this form, so now we've sort of eliminated the problem of having an integral there, and that's what we're trying to do. So now its limit as h goes to 0, 1 over h times h of f of c. So the h's now cancel, and because c is squeezed between x plus h and x, when h goes to 0, c will go towards x. So as the limit of h goes to 0, the limit of c is equal to x. And since f is continuous, it'll preserve this limit. So the limit is equal to f of x.